You should videotape mine too. Just point it that way.
4, 5, 6. 1, 2, 3, 4, 5, 6. Wonderful, and our excellent little gate. It makes me happy that you're our gate.
Go down
Okay,
like
so
the rest of it.
You're filming the ceiling,
There you go.
and then more importantly, you can't theme me.
Okay, so you guys are funny. We've got 6 people on the inside of the cell. Okay, you guys over there, you're on the inside of the cell.
Inside.
Okay, you guys over here, you're on the outside of the cell.
We're potassium.
Okay, you guys are going to be my potassium ions. You guys are going to be my sodium ions. Now what I need to do is, I need to separate inside the cell, who's going to be potassium, who's going to be a negative
I can be a
ion.
positive.
You want to be potassium?
Sure.
Okay, so why don't we just split it straight in half? Okay, so you guys, positive ions, you guys, oh no, sorry, not straight in half. You 4, positive ions, you 2, negative ions. You won't have to move. You get to stay right there. Okay, so we've got our 4 potassium ions and our 2 negative ions or negative atoms. Okay?
Okay.
On this side, over here, what do we need?
2 positive, 4 negative.
Not necessarily. We need more positivity on this side of the cell. So we've got,
You need all
sodium,
positive or
sodium,
negative.
sodium, well, pretty much you guys can all be sodium. Actually, I'll make 2 on the end there. You guys will be chlorine. Okay, or chloride ions. You're going to be negative ions.
I want to be chloride.
Chlorine 2. Okay? So we've got 4 negative, 2 positive, 4 positive, 2 negative. Now, what does that mean across the cell membrane?
Right now we're at a resting potential
Why?
because we are at -70
We are equal.
Negative 70
millivolts.
millivolts. Okay, wonderful. The increased negativity inside the cell brings it to that resting state of -70. The increased positivity out here, which is what balances that negative out here, means that, okay, this is all resting right now. Resting membrane potential. Does that make sense?
Yes.
Okay, wonderful. Now we want to talk about graded potential first. Okay, so graded potential are small changes to the membrane potential. Okay, small changes. Okay, so if I were to come in, I'm your extra cell over here that's going to change something on you guys. Okay, and I'm going to say, well, I'm just going to want you to go to -60 millivolts.
So I'm
No, negative 60 millivolts. I want to depolarize you, but
someone
only a
needs-
little tiny bit. What would happen?
someone would come to our side.
Make it more
Yeah.
positive. Right? So, okay, there we go. We got our 1 positive sodium ion entering the cell. And now you guys are at negative 60.
tapes.
Right? It's not close enough to actually create an impulse, an action potential, but it's bringing it a little bit closer. Okay? Okay, wonderful. Now what I want to do is, I'm going to be a different cell now, and what I'm going to say is I want to have an inhibitory effect. I want to make you more negative. What has to happen? You can come back out of the cell.
So all the positives come out of it?
I want to get you to negative 80.
The
Let's go
positive.
10. So we have a positive cell, or I should say a. What are you doing? Yeah, you're down. Okay, looks like you were a negative cell for a second. Okay, we got one of our positive potassium cells decided to do what?
Leave.
Leave the cell. Okay, so now you guys are now negative 80. Okay, I want you to go back in for a second. What's another way that we can make the inside of the cell negative?
Bringing one of their negatives.
Let's introduce a chloride ion.
Hi,
Now you
chloride.
guys are more negative.
How's it going?
You're
Okay.
negative 80. Okay?
Can I leave meow?
Just give me 1 second.
Do you not like us?
Now, in the graded potential, this is called what? When you go from a resting state to a more negative state?
Repolarizing.
No.
Hyperpolarizing.
Hyperpolarizing. Good. Wonderful. Repolarizing, we only really get there with action potential. Okay? There's a little bit of repolarizing to bring it back to resting state. But once resting state is there and we want to make it more negative, it's called hyper.
Is that after hyperpolarizing?
No, this is graded
Oh
potential.
my
This is
gosh.
just graded potential, remember? Okay? So that's just hyperpolarizing. Okay, let's go back to our resting state.
Okay.
All right, so now what I want to do is I want to cause an action potential. Okay? I want to make the inside of the cell raise to minus 55 millivolts. What has to happen?
I leave.
Negative.
I stay.
Stay.
We stay. We need more
Positives go
positives.
in.
Positives go in.
Positives go in.
Wonderful. So my sodium ions will get, 2 of you to go in there. Okay, so now those positive ions have increased the charge inside of the cell to what? What did I say?
Negative 55.
Negative 55, which is also called threshold. Wonderful. Awesome. Okay, so now that that has occurred, what can happen along the rest of the cell?
I don't know. You have me lost.
Anybody?
Action
An
potential.
action potential. Good. A nerve impulse can happen. Okay. So now let's pretend. Okay. Right now we're at the axon hillock. Right. The trigger zone of the axon hillock. We've gotten to negative 55, and now we're moving on to the next section of the. Sorry. Come back out now. Okay. Come back out. Now we're at the next section of the axon. You guys are just going to be going back and forth, by the way, just so you know. We're at the next section of the axon.
Okay.
And that axon can go all the way up to positive 30 because of the change of the axon hillock. What has to happen? So all of the positive ions have to go into the cell.
You're so positive. Look at those smiles.
Okay, so now all of the positives are inside of the cell. You guys are now positive 30. And if we were to do it again, and again, and again, and again, we would be going down the axon in each section of the axon. Does that make sense? Yeah?
Like, would this occur at every?
We were doing continuous conduction, it would occur at every single step of the way.
Oh.
If we were to do it saltatory conduction,
If it
it
every
happens every
row,
note.
note of. Okay.
every node of Rangier. Okay, wonderful. Now, for this section that we're in right now, okay, we've done our thing, it's gone on to the next section. Now something has to happen to repolarize the cell. Do you remember what that is? Anybody? My sodium ions are sitting there going, well, don't we come back out? No, you don't come back out.
I
No,
go out.
no, the negatives.
No,
I leave.
all of the potassium ions now have to leave the cell. Come on out, you guys.
I'm a
All of
negative though.
All of them.
You're not a negative.
No, you're a positive.
You're positive, remember?
Yeah, they're negative.
They're negative. They get to
So
stay. They don't get
they
to
were.
All of them.
You've gone dim again. I don't know if that changes anything on your computer.
No.
Okay. Hold on. Just give me 1 minute. Okay.
Okay.
Okay. Wonderful. Now we're back to a resting membrane state, right? We've got 4 positive inside, 4 positive outside, right? So you're then back to resting. And now what happens is the sodium-potassium pump brings back normalcy. So you guys are going to come out, you guys are going to go back in, and it all comes back to normal.
Right. Okay, now I got it.
Okay? So go ahead, go back to normal. You guys can just walk around the other side if you want to. There'll be an extra gate over there. Or 10 gate.
Maybe it's because your legs are something.
Okay, so at the exact same time, that point, this is when that refractory period is going to happen for this particular section, right? Because there has to be time for the sodium ions to come out, for the potassium ions to go back in. And now again, we're still at resting state. Does that make sense?
Mm-hmm.
And that's going to happen to every single node or every single section, depending on what type of conduction you're using. Okay? Okay. Now the other thing we have to think about here, Christy, can you do it? Did it again! Kirsten, can you just push the table that way so there's another little gate there? Okay, so one thing you have to be thinking about with action potentials is when we're trying to depolarize the cell or depolarize the section that we're looking at, the sodium ion gate, which is our beloved Lana over there, okay, the sodium gate opens very quickly, right, to allow that sodium to rush in the cell. At the exact same time, this other gate over here that Kirsten opened up for us is slowly opening to allow those potassium ions to come out to repolarize the cell. Does that make sense?
I'm so lost.
What are you lost on?
Everything.
Why?
I understood it all before, and then you just got me real lost.
Okay, I'm going to become a gate.
I feel like I'm in a dark hole.
Dun, 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 dun. Lana, we're going to be opposing gates. Okay? You are a sodium gate. I am a potassium gate. Okay?
Yep.
Okay, wonderful. Now the sodium gate,
reach the gate.
say we want to depolarize this part of the cell. What has to happen? That's the sodium gate.
It has to
Depolarize.
go negative 30, right?
Positive.
So in
30.
What?
your
Positive. Okay, to depolarize a cell, it has to become less negative.
so positive is gonna come to this side.
Less negative on the inside.
So that's
Less so positive is definitely all the positives have to come. Doesn't matter which gate we go.
You are sodium, right?
Over
Yeah.
here.
So the sodium gate has to be the one.
okay. Yeah, they're coming to us, but we become negative 30.
Hold on, let me get in the cell. Everybody, all the positives from
All
this
the
side.
positives come over here.
You do.
Oh God.
Yeah, boy.
How did you get so confused?
Oh, you are completely and utterly correct, my dear. I understand why you're confused at the moment.
I'm so confused.
Okay, so you guys, let's just think. You guys are potassium, right? You're a
Yes.
positive charge. You guys are negative charges, but you guys hold more of a charge. Say these guys each hold positive 1. Sorry, I should have explained this at the beginning. You guys each hold a positive 1 charge. Both of these guys hold a negative 6.
Right.
So it's more negative on the inside of the cell.
So we are always at a negative 70.
Mhm.
Even though we're positive charges, we're always
You
at
guys
negative
are our
70.
positive charges.
So when
You're
they
still
come
negative
in,
70.
we become negative 30.
You can become negative 30, but you can actually go all the way up to positive.
Positive.
Okay? Okay? Makes
See, I
sense?
wasn't confused. It's just my intelligence was like skyrocket there.
See, now, as positives,
Hold on. Yeah, okay. So at the exact same time that her gate opened, so our sodium gate opened, I was opening, but oh gosh, it takes me forever to open. Oh my gosh. So by the time they're all in, it's a time you guys can start coming out of the cell. So you guys
So
can come
now
out this way.
we're repolarizing.
Yes. You guys are now repolarizing the cell.
And then the
So now what,
And
are
then
we
this-
back at a resting? We're not back at resting, but what is this called?
This is still right now a resting state because
Oh,
now
we
the
are?
inside of the cell is back to
Negative 70
negative 70
millivolts.
millivolts.
But we're on the wrong side.
Exactly.
So we have to correct ourselves.
You have to correct yourselves. There's going to be a sodium-potassium pump, and we'll just say that on either side here is the sodium-potassium pump. So the sodium ions are going to be slowly pushed out, and the potassium ions are going to be slowly brought back in one by one at the same time. So, Brandy, if you would, walk around me. Mitch, if you would, walk around that way. Now you see, one sodium out, one potassium in.
But as we do this, we end up after hyper.
No,
Polarizing.
you're, well, right now, not yet. Right now, it's just one for one.
Yeah.
Positive
To keep the
positive.
resting
So, okay,
membrane.
Clarissa, your turn. And Tony, you too. Come back around. And you go back around that way. Wonderful. And then Trisha, Jennifer. 1 and 1. Same time. Wonderful. And you guys, 1 and 1 at the same time. Now we are back to resting fully the way it's supposed to be. Okay, where are my negative charges on this side? The two of you? Okay, so there is a possibility that there's going to be something called after hyperpolarizing, which says or states that the inside of the cell becomes more negative after an action potential. Okay, so that's where you guys want to. We'll just make you a chlorine gate now. You guys can both enter the cell and now have caused the cell to become more negative.
This only happens for a
So
short
that's
time.
very short time. That's
After.
after hyperpolarizing.
So is
and it's,
like this is like negative 95, right?
Negative 90.
90, negative 90.
and this would be because they possibly have snuck.
The negative ions possibly have snuck through,
Well,
or
the gate is
there's
open.
not as much potassium in the cells as there should be.
Right.
So
Okay.
is it because just the action potential happened so quickly that it didn't have time to adjust? So it's after hyperpolarizing, but then it goes back to a normal resting state.
Yep.
Okay.
Okay, so let's get back to resting membrane. Everybody sort of catch that? Does that sort of make sense?
That
How
one
it's
I did,
going?
yeah.
Okay.
So graded potential is just repolarizing or depolarizing.
Depolarizing
And hyperpolarizing.
and hyperpolarizing. It does a little bit of
Hyperpolarizing.
repolarizing, but we don't talk too much about it because it doesn't matter as much as the repolarizing for action.
Okay, so it depolarizes and then hyperpolarizes. Okay. And it hyperpolarizes to become at a resting state again.
Mhm.
And there's no after hyper.
There is no after hyperpolarizing because there is no action potential. It's called after hyperpolarizing
so
because
like
of the
something
action.
happens for an action potential to happen, but it doesn't follow through? Is that kind of what it's like?
I don't understand the question.
Like it's graded because an action potential was started, but it doesn't stop?
Graded happens before an action potential. Graded is what causes an action potential to happen. Okay, the graded potential causes the cell body, the dendrites in the cell body, to become that threshold that we need to create an action potential. Once the threshold is created from the graded potential, an action potential occurs.
And that's why you have to do the negative 55 first. Then you can go into the negative 30
Or the
plus
positive
30.
Are you maybe wondering why it becomes hyperpolarized? Is that
I just don't understand the difference between graded and action potential. I don't know.
Okay, you want to stop her for me, and we're going to go on to
Stop it.
onto the board.
Is there a button?
Okay. So let's say